Hello everyone. Welcome back to another week of MakerGirl online curriculum. This week, our theme is 3D printing in the biomedical industry. If you haven't checked out our introductory videos, we recommend going back and watching those now. These videos will walk you through how to use the design program used in this session and introduce you to MakerGirl and 3D printing. Here are a few questions to get you thinking about the topic of today's deck. To begin, do you know what biomedical engineering is? Biomedical engineering is a specific type of engineering that focuses on creating technologies to help people when they are sick or have an injury. They use math and science to create machines and equipment for doctors to use, but also new limbs like prosthetic legs, dentures, which are new teeth, and more. There are many different engineers in our world that use creative skills to create new innovations. Today's focus is the biomedical engineers and how they help patients like you and me every day. Today we are going to learn about how 3D printing and other STEM subjects are used in this field of biomedical engineering. We will first brainstorm design ideas on paper. Then we will create these designs on Tinkercad, the free online platform for 3D printing design. Everyone will share their design with their family. We have also provided supplemental activities related to biology and medicine for you to complete at home as well. Do you know what STEM stands for? Take a minute and come up with an answer. Hint: you learn about these subjects in school. The S in STEM stands for science. T stands for technology. E stands for engineering. And M stands for math. So what is 3D printing? Is a 3D printer the same as the printers we use to print papers and documents? Take a minute to think of an answer. We will now watch this video to better understand 3D printing.
So 3D printing is taking over the world, but how does it actually work? Well, it's quite similar to a normal printer, but then a little different. First, you don't put in an ink cartridge, but instead connect a spool of special printing material like plastic, rubber, or even metal. And you don't print boring text documents, but real-life models of what you've just made on your computer screen. Simply awesome. Right now, you can buy a 3D printer yourself and make complex 3D models with modeling software. But if you're not really a wizard with all that technical stuff, you can buy personalized 3D models online, like fancy toys, bracelets, or phone cases. Then send it to a 3D print shop nearby, choose a material, and pick up your own unique item. Sweet. In the medical world, they're developing 3D printers with special biological material. They're working on printing heart valves, ears, bones, skin, and even printed a small human kidney that can live for 3 months. It's just amazing. And hold on to your seats. They're developing a 3D printer that can print in space and are planning to print a moon base. A moon base! But, still, the coolest thing you can print with a 3D printer is another 3D printer. Booyah!
Now that you understand what 3D printing is, how can they use this printer in the medical field? Take a minute to brainstorm some ideas. They even mentioned a few ways in the past video. The following video explains one way that doctors, engineers, and researchers have been using 3D printing in healthcare. Let's take a look.
There are currently hundreds of thousands of people on transplant lists waiting for critical organs like kidneys, hearts, and livers that could save their lives. Unfortunately, there aren't nearly enough donor organs available to fill that demand. What if, instead of waiting, we could create brand new, customized organs from scratch? That's the idea behind bioprinting, a branch of regenerative medicine currently under development. We're not able to print complex organs just yet, but simpler tissues, including blood vessels and tubes responsible for nutrient and waste exchange, are already in our grasp. Bioprinting is a biological cousin of 3D printing, a technique that deposits layers of material on top of each other to construct a three-dimensional object, one slice at a time. Instead of starting with metal, plastic, or ceramic, a 3D printer for organs and tissues uses bioink, a printable material that contains living cells. The bulk of many bioinks are water-rich molecules called hydrogels. Mixed into those are millions of living cells, as well as various chemicals that encourage cells to communicate and grow. Some bioinks include a single type of cell, while others combine several different kinds to produce more complex structures. Let's say you want to print a meniscus, which is a piece of cartilage in the knee that keeps the shin bone and thigh bone from grinding against each other. It's made up of cells called chondrocytes, and you'll need a healthy supply of them for your bioink. These cells can come from donors whose cell lines are replicated in a lab, or they might originate from a patient's own tissue to create a personalized meniscus less likely to be rejected by their body. There are several printing techniques, and the most popular is extrusion-based bioprinting. In this, bioink gets loaded into a printing chamber and pushed through a round nozzle attached to a print head. It emerges from a nozzle that's rarely wider than 400 microns in diameter and can produce a continuous filament roughly the thickness of a human fingernail. A computerized image or file guides the placement of the strands, either onto a flat surface or into a liquid bath that'll help hold the structure in place until it stabilizes. These printers are fast, producing the meniscus in about half an hour, one thin strand at a time. After printing, some bioinks will stiffen immediately. Others need UV light or an additional chemical or physical process to stabilize the structure. If the printing process is successful, the cells in the synthetic tissue will begin to behave the same way cells do in real tissue, signaling to each other, exchanging nutrients, and multiplying. We can already print relatively simple structures like this meniscus. Bioprinted bladders have also been successfully implanted, and printed tissue has promoted facial nerve regeneration in rats. Researchers have created lung tissue, skin, and cartilage, as well as miniature semi-functional versions of kidneys, livers, and hearts. However, replicating the complex biochemical environment of a major organ is a steep challenge. Extrusion-based bioprinting may destroy a significant percentage of cells in the ink if the nozzle is too small, or if the printing pressure is too high. One of the most formidable challenges is how to supply oxygen and nutrients to all the cells in a full-size organ. That's why the greatest successes so far have been with structures that are flat or hollow, and why researchers are busy developing ways to incorporate blood vessels into bioprinted tissue. There's tremendous potential to use bioprinting to save lives and advance our understanding of how our organs function in the first place. And the technology opens up a dizzying array of possibilities, such as printing tissues with embedded electronics. Could we one day engineer organs that exceed current human capability, or give ourselves features like unburnable skin? How long might we extend human life by printing and replacing our organs? And exactly who and what will have access to this technology and its incredible output? For more mind-blowing medical advancements, check out.
And that is just one way. They have also made developments to create new bone, cartilage, medical tools, and skin. A very recent application of 3D printing in medicine is their use in creating materials to fight the current coronavirus pandemic. Personal protective equipment has been a key tool in helping doctors and nurses stay healthy when they are caring for coronavirus patients at the hospital. Our friends at the University of Illinois at Urbana-Champaign, CITL Spaces, and their Tech Hub staff have printed over 2,600 adjusters for face shields. The MakerGirl team usually houses our printers in their space, and we run our workshops there. The design was created by the Health Maker Lab at UIUC and will continue to produce PPE for healthcare workers. Now we are going to start brainstorming our 3D print design ideas. Take some time to think about what you would like to design. Try to think of something that is related to medicine and biomedical engineering. This could be something you saw in the video, a design you believe could help healthcare workers fight coronavirus, or anything else related to the field. Be creative. Pause this video. When you are ready for the next step, press play. I am sure you have created an awesome design. We will now bring it to life using Tinkercad. If you are unfamiliar with Tinkercad, watch our introductory video about how to get started. A few reminders. Keep everything on the blue work plane. Avoid having floating objects or objects that are below the plane. The 3 shapes on the screen are shapes that are difficult to print in the printer. It is best to avoid these shapes if you plan on printing in a 3D printer. Have fun and be creative. It takes practice, so keep working hard. Pause this video. When you are ready for the next step, press play. In a typical session, the next step is to print your design on the 3D printers. Look out for more information on how to be one of 3 lucky participants to get your print printed and sent to your house. Typically, we will save your design on your computer and drag it onto this little SD card. The card is then plugged into the 3D printer. When the printer begins to print, the plastic material reaches a very high temperature so that it all melts. The melted material comes through the nozzle and begins to mold into your own unique design. Now, share your Tinkercad design with your family. Tell them what shapes you used, how you came up with your idea, and what you learned about STEM and 3D printing. Some questions to think about are, what was the hardest part of designing? What was your favorite thing you learned about 3D printing? There are many women that have become an integral part of medicine throughout history. Elizabeth Blackwell was the first woman to earn a medical degree and practice medicine as a doctor. She paved the way for many women doctors and medical researchers. She wrote a book documenting her journey called Pioneer Work in Opening the Medical Profession to Women. Next, we have another at-home activity for you to participate in. By following the attached link, you will learn how to extract DNA in a virtual laboratory setting and learn about what DNA extraction can be used for. Do you know what DNA is? DNA stands for deoxyribonucleic acid. Everyone has their own unique DNA in their cells that carries all the information telling your body how to look and function. It is your DNA that makes you, you. A few fun facts about DNA. DNA can be used to analyze forensics evidence. This means that it can be used to solve crimes. Your DNA could stretch from the Earth to the Sun and back about 600 times. Every human being shares 99% of their DNA with every other human. The other 1% is what makes you unique. Thank you so much for being a part of our online curriculum. We will see you again next week. Have fun and stay safe.